Hi everyone, welcome back. So in this video, we're going to do how to find domain of composition of functions. So let's dive in. So here is our first example. So before we find the domain of the composition, we're actually going to find the composition first and then look for its domain. So we're given two functions, f and g, and we want to find part A, what is f circle g? So f circle g of x, simply just f of g of x. So we take the function g and we plug that into f. Well, what is g of x in this case? It's given to be 3 over x. So now that becomes our input for the function f. So we have f is going to do 2 over x minus 1, while x is 3 over x minus 1. So that's the composition. So let's go ahead and simplify this. So we have 2 over 3 over x, and I'm going to multiply 1 as x over x. So we have minus x over x, which will simplify to 2 over 3 minus x over x. And then by doing further simplification, this is simply 2x over 3 minus x. So that's our result for the composition. Now let's get to how to find the domain of this function. So to find the domain of the composition, so that's part B, well, first thing you want to look at, what is the domain of the function g? Because that's the function you inserted into f. So first you need to know what is the domain of g of x. So we know g of x is this function, 3 over x, but we know x cannot be in the domain of g. So we know x cannot be equal to 0. So now that we know 0 is not in the domain of g, that means 0 is also not in the domain of the composition. Now second, you're going to look at your function after you have performed the composition, which is this function, 2 over 3 minus x. So we got 2 over 3 minus x. Sorry, it's 2x over 3 minus x. So now we need to make sure what values are not in the domain of this function. So we know x equals 3 is not in this function, so we know x cannot be in the domain of the composition. So we know that the domain of f circle g, it's going to be all real numbers except 0 and 3. So we'll write that in interval notation as infinity to 0, union 0 to 3, union 3 to infinity. So that will be our domain for the composition. So just to recap one more time, when you're looking for the domain of composition, first you want to find the domain of the most inner function, which is g in this case, and then you look for your resulting function after the composition, and you look for what values are not in the domain of this function. And then putting those two ideas together, you get the domain of the composition. Okay, so let's try another example. So let's try this one. So here again, I have two functions, and we want to find what is the domain of f circle g, and then we'll also do the composition f circle g. So let's find what is the composition result. So f circle g is going to be f of g of x. So we take g of x, in this case is the square root of x, so we'll plug that into f of x. And then what is f of x going to do to that? Well, it's going to do 4 over x. X is replaced with g, which is simply square root of x plus 2. And this is already simplified, so that's the composition of f circle g. Now let's find the domain of f circle g. Well, we need to look at two things. We need to look at what is the domain of g. So g of x is given to be square root of x. What's the domain of that? Well, we know the domain of this function has to be greater than or equal to 0. So we know the domain of this is 0 to infinity. And next we look at the function we got after performing the composition, which is 4 over square root of x plus 2. And what is the domain of this piece? Well, that's going to be, well, we know the denominator cannot be 0. So it looks like the domain of this piece is going to be also 0 to infinity. Because there is no real number between 0 to infinity that will not satisfy this function. So putting 1 and 2 together, we have the domain of f circle g, which will be 0 to infinity. So that's the domain of the composition. All right, so this is it. I hope this makes sense.